Hello and welcome. I'm going to be answering NECO 2018 Chemistry Objective Past Question 1. Which of the following methods is used in separating a mixture of ethanol and water from palm wine? A. Crystallization, B. Decantation, C. Filtration, D. Fractional distillation, E. Precipitation. So you have a list here of some separation techniques amongst the options, and you are asked for the one which is best used in separating a mixture of ethanol and water from palm wine. So let's take a look at what each of the separation techniques are used for, or their basis of operation. Now, crystallization is used to separate solutes or salts that readily decompose on heating from their solutions. Option B, which is decantation, is used to separate a mixture containing a solid and liquid portions, which separate into two distinct layers on standing. Option C, which is filtration, involves use of a porous material such as filter paper to separate insoluble particles from liquids. Option D, fractional distillation, is used to separate a mixture of two or more miscible liquids, that is, liquids that mix. And lastly, option E, precipitation, is used to separate a solute from a solution using its difference in solubility in two different miscible liquids. Okay, so from this now, the mixture of ethanol and water and palm wine are all miscible liquids. Ethanol and water are miscible liquids. So the best, or the separation technique we described that can be used to separate miscible liquids, a mixture of miscible liquids, is option D, fractional distillation, used to separate a mixture of two or more miscible liquids. So option D, fractional distillation, is the best method that can be employed in separating a mixture of ethanol and water from palm wine. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 2. Which of the following hydrocarbons can undergo substitution and addition reactions? So you have A, C2H4, which is ethene, B, C3H8, which is propane, C, C4H10, which is butane, D, C6H6, benzene, and E, C6H12, which is hexene. So you have these hydrocarbons, and you are asked which can undergo both substitution and addition reaction. Now, the rule of thumb to remember here is that alkanes undergo substitution reaction, and the alkenes undergo addition reaction. Meanwhile, benzene, that is C6H6, benzene undergoes both addition and substitution reactions. So in its addition reaction, it forms formation of an example of the addition reaction involving benzene is formation of cyclohexane by a mix of benzene vapor and hydrogen with nickel as catalyst. And then an example of the substitution reaction is when chlorobenzene is formed. So ethene and hexene are alkenes, and we have established that they undergo just addition reaction. And then propane and butane are alkanes, and we have established the fact that they undergo only substitution reaction. And then we said benzene can undergo both substitution and addition reaction. So the correct answer is D, C6H6, benzene. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 3. The energy conversion in an electrolytic cell is A. Electrical to chemical, B. Electrical to light, C. Electrical to mechanical, D. Chemical to electrical, E. Chemical to mechanical. So in an electrolytic cell, electrolytic cell is basically like the setup used in electrolysis. And diagrammatically it looks something like this, consisting of two electrodes immersed in aqueous solution of a salt with ions that are likely to dissociate, and then you have these electrodes connected. You have the two electrodes connected to a power source. So this is what the setup kind of looks like. You have the power source, you have the electrodes, and you have it in an aqueous solution of a salt. So basically what happens in an electrolytic cell setup is that by the time the voltage or the electrical power flows through the electrodes and gets into the solution, what happens is that there will be what is known as a non-spontaneous redox reaction. So what will happen is that these ions, the constituent ions of the salt in the aqueous solution, will dissociate and migrate to the respective electrodes. So that's what happens in an electrolytic cell. Now if you look at what is happening here, you have electrical energy from the power source, from the voltage source. You have electrical energy passing and into the electrodes, which then causes dissociation of the aqueous solution of the salt and migration of ions. So what is happening here is that the electrical energy is being converted to chemical energy, because like I said, what will occur when the electrical current gets into the solution is non-spontaneous redox reaction, which is a chemical process. So it is electrical energy being converted to chemical energy. So electrical to chemical is option A, and is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 4. A cement factory is usually cited where dash is found in commercial quantity. You have A, Al2SO4 and then bracket 3. This is aluminium sulfide. B, CaCO3. This is calcium carbonate, or popularly known by its common name, limestone. C, FeS iron 2 sulfide. D, MgCO3 magnesium carbonate. E, PbCO3 lead 2 carbonate. So we are asked where a cement factory is usually cited. So it is cited where there will be abundance of, it will be cited where there is abundance of the raw material that will be used in its production. And the raw material used in cement production is limestone. Limestone is the raw material used in cement production. Now, limestone is the common name of the chemical compound CaCO3, which is calcium carbonate. So basically, limestone is made up of crystals of calcium carbonate. Calcium carbonate is option B, so it is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 5. A solution which resists changes in pH when a small amount of an acid or a base is added to it is known as A, acidic, B, basic, C, buffer, D, neutral, E, saturated. So let's look at the meanings of each of the options and see which one best fits into this description given to us as the question. Now, option A, which says acidic, an acidic substance is a substance that has a pH value of less than 7. Now, option B, which is basic, a basic substance has pH value of greater than 7. Now these values are on what is called the pH scale. So 7 on the pH scale and also on the pH scale. Now option C, which is a buffer. A buffer is a solution that resists changes in pH when small quantities of an acid or a base is added to it. So that's the definition of a buffer. Now option D, a neutral substance, is a substance with pH value of 7. And lastly, option E, a saturated substance or a saturated solution is a solution that contains as much solute as that can be dissolved by the solvent. So these are the definitions of the options, the 5 options given to us. And from these definitions, we see that option C, which is buffer, you would agree with me that we define it as a solution that resists changes in pH when small quantities of an acid or a base is added to it. Now this is basically the same definition that was given to us in the question, so it matches that definition. So a solution which resists changes in pH when a small amount of an acid or a base is added to it is known as buffer, which is option C. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. are characteristics of enzymes except they are A. Inorganic compounds, B. Organic compounds, C. Reaction specific, D. Soluble in water, E. Temperature sensitive. So enzymes, the definition of enzymes is that enzymes are biological catalysts that regulate the rate at which biochemical reactions proceed without themselves being altered. Now, we have to pick out the one which is not a characteristic of an enzyme. So, inorganic compounds. Now we've established inorganic compounds is option A. Now we've established the fact that enzymes are biological catalysts. That is, they are catalysts, substances that speed up rate of reaction or regulate rate of reaction, and enzymes are biological in nature. So, by virtue of them being biological, it means that they are organic. They are organic, or what is known as biomolecules. So they are biomolecules, organic biomolecules, and hence they are not inorganic in nature, they are rather organic in nature. So option A, which is inorganic compounds, is not a characteristic of enzymes, as enzymes are all organic in nature. So option B says organic compounds, so it is a characteristic. Option C says reaction specific. Yes, enzymes will only carry out will only affect reactions which they are supposed to affect. For example, an enzyme that is supposed to catalyze breakdown of carbohydrates, such as the enzyme known as amylase, will only catalyze this reaction. It will not catalyze breakdown of protein or any other food class. So enzymes are reaction specific. Now, soluble in water. Solubility is also one of the characteristics of enzymes, and enzymes are also temperature sensitive. So option A, inorganic compounds, is not a characteristic of enzymes and is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 7. Fluoride ions are sometimes added in the treatment of town water supply to A. Improve coagulation, B. Kill germs and bacteria, C. Make the water useful, D. Prevent tooth decay, E. Speed up sedimentation. Now, in the treatment of town water supply, there are various steps that are taken, such as coagulation, sedimentation, etc. But one of the steps involved is addition of supplements. And these supplements usually include fluorine or fluoride, ions, and also iodine. Now, these supplements are added, of course, for the various functions they perform in the human body. Now, fluorine or fluoride ions are added to prevent tooth decay, and then iodine is added to prevent goiter. So fluoride ions is added to water being treated for town supply to prevent tooth decay, and prevent tooth decay is option D. So option D, prevent tooth decay, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 8. Which of the following substances is a constituent of fire extinguisher? A. Ammonia, B. Carbon dioxide, C. Hydrogen sulfide, D. Nitrogen peroxide, E. Sulfur 4 oxide. So fire extinguishers are, of course, specially designed specially designed equipment, okay, in canisters for putting out fires. So these fire extinguishers are commonly made up of carbon 4 oxide or CO2. Now CO2 is used as the constituent, or is used as a constituent in fire extinguisher because it does not support combustion or burning. Combustion is also known as burning, so it does not support combustion, and it is heavier than air, so it envelopes the flame and starves it of oxygen supply. So this is the mechanism of action of CO2 or carbon 4 oxide that makes it to be used as a constituent of fire extinguishers. So carbon 4 oxide is option B and is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 9. An alloy that is made up of copper and zinc is called A. Alnico, B. Brass, C. Bronze, D. Duralumin, and E. Steel. So alloys are substances prepared by adding one or more elements to a base metal to give it certain desirable qualities. So basically, formation of alloys involves mixing or adding one element to a base metal, to a metallic element, to give it some certain desirable qualities or characteristics. So let's look at each of the options, the alloys in each of the options, and what constitutes those alloys. Now alnico is made up of iron, aluminium, nickel, and cobalt. So these are the constituents of alnico. Now brass is made up of copper and zinc. Bronze is made up of copper and tin. Duralumin is made up of aluminium, copper, magnesium, and manganese. And then steel is made up of iron and carbon. So these are the various constituents of each alloy given to us in the option. Now we are asked for the one that is made up of copper and zinc, and from what we've established here, option B, brass, is the alloy made up of copper and zinc. So option B, brass, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 10. What is the maximum number of electrons in the 2pz subshell? A 2, B 4, C 6, D 8, E 12. Now, the P sublevel, when you are talking about electronic configuration, using the SPDF levels. So the P sublevel contains what is known as three degenerate orbitals, and those three degenerate orbitals are the px, the py, and the pz. These are the three degenerate orbitals under the P sublevel when you are using this electronic configuration, the SPDF electronic configuration format. Now, each of these degenerate orbitals can hold a maximum of 2 electrons. So px can hold 2, okay, py can hold 2, and pz can hold 2 electrons. So each of them can hold a maximum of 2 electrons, and it has pz, 2pz. So as we have already established, the pz holds a maximum of 2 electrons. So option A, 2, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 11. If 16.0 grams of a salt is dissolved in 500 cm³ of distilled water with a concentration of 0.80 moles per dm³, the molar mass of the salt in grams per mole is A 10.0, B 14.8, C 18.5, D 40.0, E 80.0. So this question is a solubility calculation, and the solubility formula is given as mass over molar mass times 1000 over volume. So here we are given the mass of the salt here, we are given the volume of solvent here, the volume of distilled water, and we are given this concentration here is the solubility. Solubility is measured in moles per dm³. So this is the solubility. Now we are asked to find the molar mass of this salt, this particular 16.0 grams of salt. So what we need to do is to substitute and then make the molar mass the subject of the formula, and we get our answer. So the solubility here is 0.80 is equal to mass 16.0 over molar mass unknown, let's call that x, times 1000 over volume, which is 500. So multiply this by this, and this by this, and this by this. So that will give us 16,000 over 500 x 0.80 here. So what we do now is to cross multiply, and when we do that, we'll have 0.80 times 500 x is equal to 16,000. Now 0.80 times 500 x is equal to 400 x equal to 16,000. Now divide both sides by 400. Is divided by 400, is divided by 400, and x, so 400 divided by 16,000 is equal to 40.0. So 40.0 is option D. So option D, 40.0, is the molar mass of the salt in grams per mole. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 12. The type of bond formed when two elements with electronic configuration 1s2, 2s2, 2p6, 3s2, and 1s2, 2s2, 2p4 combine is A. Coordinate, B. Covalent, C. Electrovalent, D. Hydrogen, E. Metallic. So you are given two elements here, the electronic configuration of two elements, and you are asked to deduce the type of bond that will be formed between those two elements. So let's look at the two electronic configurations and try to see what elements they are, or what kind of elements they are, so we can then have an idea of the type of bond they are likely to form. So now the first one is 1s2, 2s2, 2p6, 3s2. Now to get the total electron count, you just add up all these numbers up here, you add them all together, and that will give you the total number of electrons in one atom of that element. So 2 plus 2 plus 6 plus 2 is equal to 12 electrons. And the number of electrons is equal to the number of protons. Number of electrons is equal to number of protons, and number of protons is equal to the atomic number. So if an element has 12 electrons, it means it has 12 protons, and then it means its atomic number is 12, and atomic number 12 is magnesium. Atomic number 12 is magnesium. Now 1s2, 2s2, 2p4, that's a total of 8 electrons, and similarly number of electrons is equal to number of protons is equal to atomic number. So atomic number is 8, and the element with atomic number 8 is oxygen. So we are asked for the type of bond that will be formed between magnesium and oxygen. Now looking at these two elements, magnesium is a metal, and in order for it to attain stability, it will need to donate 2 electrons, 2 of its valence electrons. And oxygen is a non-metal. In order for it to achieve stability, it will need to accept 2 electrons. And we are made to understand that the form of chemical bonding, or the type of chemical bonding that is formed by donation of electrons by a metal, which is then accepted by metal, is known as electrovalent or ionic bond. So electrovalent or ionic bond is the type of bond that will be formed between elements with these electronic configurations. An electrovalent bond is option C, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 13. Which of the following compounds has a three-dimensional tetrahedral shape? A. Benzene, B. Carbon 4 oxide, C. Ethene, D. Methane, E. Sulfur 4 oxide. So we are looking at shapes of compounds. Shapes of compounds. And we're asked for the one which has a three-dimensional tetrahedral shape. So let's take a look at the shapes of each of the options and see which one has a three-dimensional tetrahedral shape. Now, option A, which is benzene, is a planar hexagon. So this is its shape, planar hexagonal shape. Now, carbon 4 oxide has a linear geometrical shape. So its structure is arranged sort of like in a straight line, hence the name, the linear geometrical shape. Ethene is trigonal planar in shape. Methane is tetrahedral in shape. And then sulfur 4 oxide is dihedral in shape. So from the four options we have looked at, we have established that methane is tetrahedral. So this, in more detail, you can say it is three-dimensional tetrahedral in shape. So this is the shape of methane. Methane, option D, has a three-dimensional tetrahedral shape and is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. And welcome. I will be answering NECO 2018 Chemistry Objective Past Question 14. The presence of oxygen in air can be determined by passing a given volume of air through A. Acidified KMnO4, B. Alkaline pyrogalol, C. Concentrated H2SO4, D. Lime water, E. Water. So this question is asked how you can detect oxygen in a given volume of air. How can you detect oxygen in air? So the test for this usually is done using alkaline pyrogalol. Alkaline pyrogalol is used for this experiment, and how it works is that it absorbs oxygen from air, turning brown from a colorless solution. So what happens is that alkaline pyrogalol is usually colorless, but when you pass a volume of air containing oxygen, of course, it will absorb that oxygen from the air and turn brown. So it will no longer be colorless again, it will become brown. Now this way it is used to calculate the amount of oxygen in air via the OSAT apparatus. Okay, so this is just something you may take note of. The OSAT apparatus is used to calculate the amount of oxygen in air using this alkaline pyrogalol. But from the question as it asks, we are just asked what can be used to detect the presence of oxygen in air. So as we have rightly established, alkaline pyrogalol, which is option B, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 15. The petroleum product that is used for making candle is A. Ammoniacal liquor, B. Asphalt, C. Bitumen, D. Paraffin, E. Petroleum ether. So we are asked, you have all these products here are more or less petroleum products, but we are asked for the one that is used for making candles. So let's take a look at what each of the following products are used for and see the one that is used for making candle. Now, option A, which is ammoniacal liquor, is used in wastewater treatment, pulp and paper industries. So these are the major industries where you have ammoniacal liquor being used. There are also other ones, but these are the major ones. Now option B, asphalt, is used in mainly road construction. So asphalt is used mainly for road construction. Now bitumen is also used for road construction and also for roofing and paving, making of pavements, paving. Now option D, which is paraffin, is used in candle making, specifically the paraffin wax. The paraffin wax is what is used in candle making. So paraffin is used for making candles. And then petroleum ether is used as a non-polar solvent in pharmaceutical industries, scientific laboratories, and manufacturing industries. So that is what petroleum ether is used for. Now, as we have rightly established here, paraffin is what is used in candle making, specifically the paraffin wax. So the petroleum product that is used for making candle is option D, paraffin. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 16. So you have this reaction here, and we asked in the equation above, the value of A, that is this A here, is A4, B5, C6, D7, E8. So the first idea they have given to you is that this A written here is a coefficient. That is like a number to represent number of moles. So in this case, it is representing the number of moles of oxygen. So you are asked for that value. What is the value of A? What does A represent? Now, in order to find this, you check if the reaction is balanced, and from the look of things, the reaction isn't balanced. So you take a look at the number of oxygen you have on this side, and then use it to estimate the number of oxygen you have on this side. Now on this side, you have, this is 4 times 2, you have 2 oxygen in CO2, 4 moles of CO2. So in 4 moles of CO2, you have 8 atoms of oxygen. And then in 6 moles of water, you have 6 atoms of oxygen. So 8 plus 6 is equal to 14 atoms. So you have 14 atoms in total on this side. So in order for the reaction to be balanced, you must have 14 on this side. Now you have oxygen atom here, that is 2 atoms of. So how many moles will you need? In order for you to get 14 atoms in total on this side? So 14 divided by 2 is equal to 7. So it means that if you have 7 moles of oxygen on this side, 7 moles of oxygen gas on this side, you will have 7 times 2, that is 14 atoms of oxygen in total. So A is equal to 7, as 7 moles of oxygen is what we require to have a balanced reaction of 14 atoms of oxygen on this side and 14 atoms of oxygen on this side. So the value of A is 7, and 7 is option D, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 17. How many protons are there in a metallic ion Y2+, which has 18 electrons? A2, B9, C16, D18, E20. So in order to solve this question, you say for a chemically neutral atom, the number of electrons will be equal to the number of protons. Okay. However, for a positively charged ion, electrons have been lost. So for a positively charged metallic ion like this one, Y2+, some electrons have actually been lost. Now, the question says there are 18 electrons in this particular metallic ion. So the number of electrons is equal to 18. And we've established the fact that if this has 18 electrons, the ion of it has 18 electrons, that means it has lost 2 electrons. So the number of protons will be equal to 18 plus 2, which is 20. So prior to it becoming an ion, before it became an ion by losing 2 electrons, it originally had 20 electrons, and we're asked for the number of protons. So when it was chemically neutral, its number of protons was equal to its number of electrons, so its number of protons was equal to 20. So option E, which is 20, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 18. Examples of fine chemicals include the following except A. Additives, B. Drugs, C. Dye, D. Perfumes, E. Sodium hydroxide. Now, what are fine chemicals in the first place? Now, fine chemicals are single, pure, and complex chemicals that are only produced in small amounts and to very high degree of purity. Examples include drugs, dyes, perfumes, additives, etc. Now, the opposite of fine chemicals is bulky chemicals. So bulky chemicals are those that are produced in large amounts and the degree of purity is not really emphasized. So let's look at the options. Additives, we have listed additives as an example of a fine chemical. So an additive is a fine chemical and hence it's not the answer to this question. Now, drugs is the first example we listed as an example of a fine chemical, so it is not the answer. We also listed dyes, so it's out. We listed perfumes, that is also out. Now, sodium hydroxide is an example of a bulky chemical because it is produced by chemical industries in very large amounts and the degree of purity is not emphasized. So sodium hydroxide is not an example of a fine chemical. It is a bulky chemical and hence the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 19. Sodium trioxocarbonate 4-decahydrate on exposure to air loses its water of crystallization. This phenomenon is known as A. Dehydration, B. Deliquescence, C. Effervescence, D. Efflorescence, E. Hygroscopy. So sodium trioxocarbonate 4-decahydrate is a salt represented by the formula Na2CO3. So decahydrates, that is with 10 moles of water as its water of crystallization. Now, on exposure to air, it loses this water of crystallization. So we are asked for what this phenomenon is known as. So let's look at each of the options and see which one describes this phenomenon. Now, option A, which is dehydration, simply just refers to the loss or removal of water from any substance. Now, option B, deliquescence, refers to the absorption of large amounts of water on exposure to the atmosphere, such that whatsoever substance or what salt exposed turns into solution. An example is seen in silica gel, sodium hydroxide, etc. Now, option C, which is effervescence, refers to the escape of gas from a solution in liquid. A good example is when carbon dioxide bubbles escape from a carbonated drink. So that is effervescence. Now, option D, which is efflorescence, refers to when crystalline salts lose part or all of their water of crystallization on exposure to air, such as what is seen in Na2CO3 that is sodium trioxocarbonate 4 decahydrate. And then lastly, hygroscopy refers to when substances absorb moisture on exposure to air but do not form solutions. Instead, they become sticky. And an example is quicklime. So from the description we have given, we have rightly established that option D, which is efflorescence, is when crystalline salts lose part or all of their water of crystallization on exposure to air. And the example we gave was the example of the sodium trioxocarbonate 4 decahydrate. So it loses its water of crystallization on exposure to air. So the phenomenon, as we said, is efflorescence. Efflorescence, option D, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 20. Calculate the number of moles of a gas if it occupies a volume of 4 dm cube at 10 atm and minus 200 degrees Celsius. So you have this constant R is equal to 0.08 to atm dm cube per Kelvin per mole. A 73.00, B 40.00, C 6.68, D 0.56, E 0.15. So from the variables given to us in the question, this is calculation of or involving the ideal gas equation, and the ideal gas equation is given as PV is equal to nRT. Now where P is the pressure, which we have here as 10 atm, pressure in atm, V is the volume in dm cube, which we have here, N is the number of moles, R is our constant, ideal gas constant, and T is the temperature in Kelvin. So our temperature here is in degrees Celsius, so the first thing to do is we'll convert our temperature to Kelvin. So minus 200 degrees Celsius to Kelvin will be plus 273 is equal to 73 Kelvin. So we are looking for number of moles, N, and we are given the other variables. So if you make N the subject of the formula, N is equal to PV over RT. So N is equal to, so we can substitute each value now. Now P, pressure, is 10 atm times V, volume, 4 dm cube, over R, which is our constant, 0.082, times T, which is our temperature in Kelvin, 73 Kelvin. Now this is equal to 6.68 moles. So the number of moles is 6.68 moles. 6.68 is option C. So option C, 6.68, is the number of moles of the gas and the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers.
Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 21. If the density of a saturated solution of salt G is 1.12 gram per centimeter cube, calculate its solubility in mole per dm cube. Now, given that the relative molecular mass of G is equal to 58.5, A, we have 18.62, B 19.15, C 21.38, D 52.23, and E 65.52. Now we are asked to calculate the solubility of this saturated solution of salt in mole per dm cube, and we're given that solubility is equals to the given mass all over the molar mass multiplied by the given volume 1000, which is a standard volume, all over the given volume. Let's call it volume, let's call it V. But now the question says that the density of this salt density is equal to 1.12 gram per cm cube. Now this is the density of the salt. Now, and like we know, density is given as mass all over volume. Now from this expression here of solubility given as mass all over molar mass times 1000 over volume, from here we can say solubility S is equals to 1000 times mass all over molar mass times volume. And from here you see that this mass over volume is already given to us as our density, because density is mass over volume, and we're already given the density, which is mass over volume. So simply we'll say solubility S is equals to 1000 all over molar mass of this salt multiplied by its density, which is mass over volume, and that is 1.12. So from here we have that solubility S is equals to 1000 all over the molar mass, which is 58.5, then multiplied by 1.12, which is the mass over volume, which is given to us as our density. And with this, when we carry out this arithmetic, that's 1000 all over 58.5 multiplied by 1.12, we're going to be having 19.145, which is approximately 19.15. So this is the solubility of this saturated solution of salt G in mole per dm cube. So the answer is 19.15 approximately, and that is option B, 19.15. So this is the solubility of this saturated salt. Thank you and God bless you, and subscribe to the channel for more videos and past questions. Good day and welcome. I'll be answering NECO 2018 Chemistry Objective Past Question 22. Which of the following is a property of metal? Now, the property of metal includes, that's the physical property of metal now, include 1. High melting and boiling points. High melting and boiling points. 2. Metal has characteristic luster. Characteristic luster, that is, they have what? Their characteristic color peculiar to them. Metals are malleable, that is, they can be beaten into sheets. Also, metals are ductile, that is, they can be drawn into wire. Metals are sonorous, they produce notes, that is, sounds. Metals are hard, not brittle. They are hard and not brittle. Metals has relative high density, that is, when compared to other elements, relative high density. And metals are good conductors of heat and electricity. Good conductors of heat and electricity. Now let's look at the options. Option A says metals are brittle. No, like I have established, metals are hard. Option B says metals are ductile. Yes, metals are ductile, that is, they can be drawn into wires. Example are the cables you see at home. Then C says low densities. No, metals has what? High densities. D says low melting and boiling point, which is wrong. Metals has high melting and boiling points. And E says poor conductors of heat and electricity, which is wrong. Metals are good conductors of heat and electricity. So the answer to this question is option B. This is the only property of metal stated in these options. Thank you and God bless you. Subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 23. In the laboratory preparation of chlorine, the gas is passed through water before collection so as to A. Cool the chlorine gas, B. Enable the gas to be diluted, C. Increase the volume of chlorine gas, D. Remove hydrogen chloride gas, and E. Remove manganese 4 oxide. Now, in the preparation of chlorine, hydrochloric acid is actually oxidized using potassium tetraoxomanganate 7. So hydrochloric acid, HCl, that's the acid, HCl acid, is oxidized is oxidized with potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7, that is KMNO4. Now, when this is done, once this hydrochloric acid, touches this potassium tetraoxomanganate 7, what happens? A small amount of what? Hydrogen chloride will be evolved. A small amount of what? Hydrogen chloride will be evolved. Together with what? Together with chlorine gas. Now, as this gas is moved, they get to what? They get to the water before collection. Now, the essence of this water before collection is so that this hydrogen chloride gas that is evolved, that is the HCl gas which is evolved, gets dissolved. It gets what? Dissolved into the water. As it gets dissolved into the water, what happens? The chlorine gas becomes what? Pure, and so then it is what? It is collected. But initially, this chlorine gas was impure because it has what? It has part of what? Hydrogen chloride, because hydrogen chloride gas and the chlorine gas were actually evolved from this reaction. But as this reaction passes through water, it then what? This water then removes, because hydrogen chloride gas is soluble in water, so it dissolves in water, thereby releasing the pure chlorine gas, and this pure chlorine gas is then what's collected. So the essence of this water is to remove hydrogen chloride gas, which is option D. And this is the answer to this question. Thank you and God bless you, and subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 24. Helium and argon respectively are characterized by completion of their dash orbitals: A, D and F, B, P and D, C, P and S, D, S and D, and E, S and P. Now, like we know, we have 4 orbitals. That's known 4 orbitals, which are the S, P, D, F. S can contain maximum of 2 electrons, P maximum of 6 electrons, D maximum of 10 electrons, and F will take the maximum of 14 electrons. Now, helium has an atomic number of 2, and therefore its s orbital is what? Is fully occupied. That is, its s orbital is completed by these 2 electrons. And like you know, helium and argon are what? Are rare gases. We call them rare gases, or the noble gases. They belong to the group 8 or group 0, and this is because of their complete what? Octet structure. Because of their complete octet structure, they do not undergo any chemical reaction. Now, like you see here now, the helium atom has 2 electrons, so therefore the s orbital is complete. Now, for the argon has atomic number 18, and so therefore its s orbital is complete with 2, its p orbitals is complete with 6, and then its d orbitals is also complete with what? With 10, making it 18. So therefore the helium has complete s orbital, which is the outermost orbital, and the argon has complete what? D orbital, which is what? Outermost orbital. So therefore making them what? Noble or rare gases, because they have their complete octet structure. And so therefore we say for helium the s is complete, and for argon the d is complete. So the answer is S and D, and that is option D. S and D is the answer. Thank you and God bless you, and subscribe to the channel for more videos and for more past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 25. A given volume of methane diffuses in 30 seconds. How long in seconds will it take the same volume of sulfur 4 oxide to diffuse under the same condition? Given that hydrogen is equal to 1, that is the mass of hydrogen is 1, that of carbon is 12, oxygen is 16, and sulfur is 32. Now, given from Graham's law of diffusion, we have that T1 all over T2 is equal to the square root of M1 all over M2. This is from Graham's law of diffusion. Now, this T1 here is the time taken for the methane gas to diffuse, and that is 30 seconds in seconds. Then T2 is what we are looking for, that is the time taken for the sulfur 4 oxide to diffuse. Now, M1 will be the molar mass of the methane gas, and like you know, methane is CH4, and that is equals to 12 plus 4 times 1, and this will give us what? 16. So the molecular mass of methane is 16 gram. Then that of sulfur oxide is SO2, and this is equals to 32 plus 16 times 2, and this will give us 64 gram. So M2, which is the molecular mass of the sulfur 4 oxide, is equal to what? 64 grams. Now we can now find what? The time taken for this sulfur 4 oxide gas to diffuse under the same condition. Now we have T1 to be what? To be 30 all over T2, which is what we're looking for, is equal to the square root of M1, which is 16, all over M2, which is 64. Now the square root of 16 is equal to is 4, all over the square root of 64 is 8. From here, 4 will go into 8 once, and into itself once, and 4 into 8 is 2. So we have that 30 all over T2 is equals to 1 over 2. Now when we cross multiply, we have that T2 is equals to 2 times 30, which is equals to 60. So it will take 60 seconds for the same volume of sulfur 4 oxide to diffuse under the same condition, and this is because the molecular mass of sulfur 4 oxide is twice that of methane, and so therefore it will take what? 2 times the time taken for methane to diffuse for sulfur 4 oxide to diffuse, and that is option D, 60. Thank you and God bless you. Ensure to subscribe to the channel for Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 26. What is the hydrogen ion concentration of solution whose pH is 4.4? A 3.98 times 10 to the power minus 5, B 3.98 times 10 to the power minus 4, C 3.89 times 10 to the power minus 5, D 3.89 times 10 to the power minus 4, E 3.79 times 10 to the power minus 5. Now, the formula connecting the hydrogen ion concentration and pH is given as pH is equals to minus log hydrogen ion concentration. Now from this, we're given that the pH is 4.4, so 4.4 is equal to minus log hydrogen ion concentration. Now from this, we can say log hydrogen ion concentration is equals to minus 4.4. Now to get the hydrogen ion concentration, we say it is equal to the anti-log of minus 4.4, and this is equal to 3.98 times 10 raised to the power of minus 5, and this is option A. So option A is the hydrogen ion concentration of the solution with pH 4.4. Thank you and God bless you. Ensure to subscribe to the channel for more videos on past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 27. What volume in centimeter cube of 0.25 mole per dm cube of H2SO4 will neutralize 25 centimeter cube of 0.1 mole per dm cube NaOH, that's sodium hydroxide solution? A 5, B 10, C 15, D 20, and E 25. So in essence, they're asking us to find the volume of the acid, that's tetrahydrosulfate 6 acid, that will neutralize 25 centimeter cube of 0.1 mole per dm cube of sodium hydroxide solution. Now let's briefly turn down the reaction. That's the equation of this reaction now. So we have H2SO4 plus sodium hydroxide, and this will give us sodium tetrahydrosulfate 6 salt plus water. Now let's balance this reaction. So we'll have 2 here, and then we have 2 here. Now this is a balanced reaction. So 1 mole of this acid reacts with 2 mole of this base. It neutralizes 2 mole of this base. So now from here we can simply say, using the formula, CaVa all over CbVb is equals to Na all over Nb. Now we have that Ca, which is the concentration of the acid in mole per dm cube, to be 0.25 mole per dm cube. Cb is equals to 0.1 mole per dm cube. Va, which is the volume of the acid, which we don't know. Vb, the volume of the base, which is giving us 25 centimeter cube. Then Na, which is the mole of the acid, which is 1, and Nb, which is the mole of the base, which is 2. From this we can say that Cb is equal to Vb, sorry, we're looking for the volume of the acid, which is Va. The volume of the acid is Va. So from that we can say Va is equals to Cb Vb Na all over Ca Nb. That's from this equation. So we've made Va the subject of the formula by cross multiplying. So we have that Va, volume of the acid, which is what we're looking for, is equals to 0.1 multiplied by 25 multiplied by 1 all over 0.25 multiplied by 2. Now this is equals to 2.5 all over 0.5, and this is equals to 5 centimeter cube. So the volume of this acid required to neutralize 25 centimeter cube of the mole of this base is 5 centimeter cube. Thank you and God bless you, and subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 28. Now we're given this reaction, that is hydrogen reacts with chlorine to give us hydrogen chloride. Now beneath them is the heat content of each of the reactants and also the heat content of the product. Now the question says the net energy change in kilojoules for the reaction above is A minus 247, B minus 184, C plus 184, D plus 194, and E plus 247. So we are asked to calculate the net energy change. Now this is the net energy change of an equation or if a reaction is given as delta H is equal to the heat content of products minus the heat content of reactant. And now the heat content of the product here is given to us as 431 kilojoules, but because 2 moles of this product is produced, so the heat content will be what, 2 multiplied by 431, because it's 2 moles of HCl. Then subtracting the heat content of the reactants, which are 436 for the hydrogen and 242 for the chlorine. So we have that what 862 minus 678, and this is equals to 184 kilojoules. So this is the energy change in this what reaction, that's plus 184 kilojoules, which is option C. So this is the answer to this question. Thank you and God bless you, and subscribe to the channel for more videos and past questions. Hello, good day and welcome. I'll be answering NECO 2018 Chemistry Objective Past Question 29. Calculate the current in amperes required to produce 13.5 gram of aluminium in 1 hour, given that the molar mass of aluminium is 27 and 1 farad is equals to 96,500 coulomb. A, we have 13.40, B, we have 22.92, C, 26.80, and D, 35.74, and E, 40.20. So we are asked to find what the currents required to produce what this given mass of aluminium, and like we know, 96,500 coulomb will produce 27 gram of aluminium. That is 96,500 coulomb will give us the complete mass of aluminium. Now, the quantity of electricity used to produce 13.5 gram quantity of electricity, which is in coulomb, is equal to the current multiplied by the time, which is equals to the current multiplied by the time is 1 hour, that is 60 seconds times 60 minutes, and this is equals to 3,600 I, and this is in coulomb. So we can say therefore 3,600 I coulomb will give 13.5 gram of aluminium. Then now we can cross multiply. We can say 3,600 I, which is the current, multiplied by 27 gram of aluminium is equal to 96,500 coulomb multiplied by 13.59 gram of aluminium. 13.5 gram of aluminium, sorry, not 59. Now from here we can see that I is equals to 96,500 multiplied by 13.5 all over 3,600 multiplied by 27, and this will give us 13.40 amperes. So the current in amperes required is actually what 13.40 amperes, and that is option A. Thank you and God bless you, and subscribe to the channel for more videos and past questions. Hello, good day and welcome. I'll be answering NECO 2018 Chemistry Objective Past Question 30. The volume occupied by a gas at 37 degrees Celsius and 740 millimeter mercury is 100 centimeter cube. What would be the volume of the gas in centimeter cube if the pressure is increased to 2000 millimeter mercury at the same temperature? Now the options given are 37.0, B 65.5, C 74.0, D 87.5, and E 200.0. Now it is stated clearly that the temperature is constant, and so the pressure and volume changes. Now this is Boyle's law. So from Boyle's law we have that V1 P1 is equals to V2 P2. Now we're giving V1 to be equal to 100 centimeter cube. V2 is what we're looking for. P1 is equals to 740 millimeter mercury, and P2 is 2000 millimeter mercury. So from this formula we can say V2 is equals to V1 P1 all over P2, and V2 is equals to 100 multiplied by 740 all over 2000. Now this 0 will cancel this 0, this 0 will cancel this, and this 0 will cancel this. Now we have 74 divided by 2, 2 here, 1, 2 in 74 will give us 37. So the volume is equals to 37.0 centimeter cube. This is the new volume when the pressure is increased to 2000 millimeter mercury, and that is option A. So it is stated clearly that the pressure is inversely proportional to the volume, provided that the temperature is constant according to Boyle's law. So this is the answer to this question. Thank you, and ensure you subscribe to the channel for more videos and past questions.
Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 31. To what temperature in Kelvin must a gas be raised from 290 Kelvin in order to double both its volume and pressure? A. 145, B. 580, C. 819, D. 1092, E. 1160. So we are given an initial temperature here of 290 Kelvin, and we are asked, to what temperature will you raise this gas to in order for its volume and pressure to both be doubled? So the formula that gives us the relationship between volume, pressure and temperature of a gas is the general gas formula or general gas equation, which is P1 V1 over T1 is equal to P2 V2 over T2. Now let's look at our variables. Our T1 is 290 Kelvin. Our T2 is what we are looking for because we are asked to what temperature. So our T2 is what we are looking for. And then our P1, let's hypothetically just leave it as P1. Our V1, so let's also leave it as V1. Now our final pressure and volume is supposed to be what? To be double the volume and pressure. So P2 is equal to 2P1, that is 2 times P1, and V2 is equal to 2V1, that is 2 times V1. So now, from this general gas equation, like I said, we are looking for our T2. And if you make T2 subject of formula, T2 will be equal to, from this formula, T2 is equal to P2 V2 T1, that is P2 times V2 times T1, all over P1 V1, P1 times V1. So this is the expression to get our final temperature. Now let's substitute each value. Now P2 we said is 2P1, that is double the value of P1. So 2P1 times V2, which is 2V1, times T1, which is 290 over P1 V1. Okay, so you have P1 here, so P1 cancels P1, V1 cancels V1. So T2 is equal to 2 times 2, which is 4, times 290. So T2 is equal to 4 times 290, which is equal to 1160 Kelvin. So this is the temperature to which you must raise this gas in order for its volume and pressure to be double. So 1160 Kelvin is option E, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 32. Astatine in group 7, okay, this is group 7 of the periodic table, has similar chemical property with A. Aluminium, B. Carbon, C. Iodine, D. Oxygen, E. Phosphorus. So we are given the group of this element, group 7. We write it out here. This is group 7. We are given the group of astatine, and we are asked for the elements which it has similar chemical property with amongst the options. Now the important thing to note is that elements in the same group have similar chemical properties because they have the same number of valence electrons. So this is why they have similar chemical properties. Now, for us to pick the answer to this question, all we have to do is pick out the element amongst the options that belongs to the same group as astatine, which is group 7. Now, aluminium belongs to group 3, carbon group 4, iodine group 7, oxygen group 6, phosphorus group 5. So from what we've established here, iodine belongs to group 7, which is the same group as astatine. Hence, it has similar chemical properties because it has the same number of valence electrons as astatine. So option C, iodine, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 33. So you have this reaction here involving ethanoic acid giving off methane and carbon dioxide. Now the reaction above is called A, acidification, B, carboxylation, C, decarboxylation, D, esterification, E, neutralization. Now the first thing to note in this reaction are the products of the reaction. So you have methane and you have carbon dioxide. Now any reaction that involves removal or involves carbon dioxide is known as a decarboxylation reaction. Now in a decarboxylation reaction, what happens is that a carboxyl group is removed from a compound and carbon dioxide is evolved. So as you can see here, carbon dioxide is evolved as a result of a removal of a carboxyl group from this compound. So decarboxylation is option C, which is the correct answer to the question. Now for clarity, acidification involves a reaction that involves addition of an acid to a compound. Carboxylation involves addition of a CO2 group or carboxyl group. Decarboxylation involves removal of a carboxyl group. Okay. Esterification is when esters are formed. Esters are formed as a result of reaction between alkanol and carboxylic acid to produce water plus this ester. Okay. And then neutralization is the reaction between acid and base to give salt and water only. So as you can see, decarboxylation involves removal of a carboxyl group to give CO2, carbon dioxide, which is what we have in the reaction. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 34. Which of these gases can be collected by downward delivery? A, ammonia, B, chlorine, C, fluorine, D, hydrogen, E, nitrogen. So what in the first place is downward delivery? Now downward delivery is a method used in collecting gases which are more dense or heavier than air after preparation, after they have been prepared. So after they have been prepared, gases that are more dense than air are collected by its method known as downward delivery. Now examples of gases that are collected by downward delivery include carbon dioxide, chlorine, sulfur dioxide, hydrogen chloride gas, etc. So all these gases, they are more dense than air. Now amongst the options we have listed chlorine. So chlorine B is the answer to this question. It is the gas that can be collected by downward delivery. Every other gas amongst the options is collected by upward delivery, which is a method used to collect gases that are less dense than air. So as you have established, chlorine is more dense than air and hence is collected by downward delivery. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 35. When ethanol is heated with excess concentrated tetraoxosulfate 6 acid, the organic products formed is A. Ethane, B. Ethanoic acid, C. Ethanol, D. Ethene, E. Ethine. So this reaction, ethanol being heated in the presence of excess concentrated tetraoxosulfate 6 acid, is known as a dehydration reaction. So the reaction is called the dehydration of ethanol using excess concentrated tetraoxosulfate 6 acid. Now, when this happens, the reaction yields, first of all, yields a product known as ethyl hydrogen tetraoxosulfate 6. It yields ethyl hydrogen tetraoxosulfate 6, given by this formula C2H5HSO4. Now, this product, ethyl hydrogen tetraoxosulfate 6, further decomposes to yield the final organic product of C2H4, which is ethene, and also yields tetraoxosulfate 6 acid. So this is the summary of the reaction. You have ethanol C2H5OH reacting in the presence of tetraoxosulfate 6 acid, concentrated tetraoxosulfate 6 acid, to yield ethyl hydrogen tetraoxosulfate 6. This is it. Okay, and water. Now we said this, the ethyl hydrogen tetraoxosulfate 6 will further decompose. Okay, this will further decompose to yield ethene and tetraoxosulfate 6 acid. So this ethene is the organic product of the reaction involving ethanol and concentrated tetraoxosulfate 6 acid, and ethene is option D, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 36. Boiling of liquid is said to occur when A. Its vapor pressure is equal to atmospheric pressure, B. Its vapor pressure is equal to the vapor density, C. Its volume is slightly increased, D. The density of the liquid is greater than 1, E. The molecules start escaping from its surface. Now, boiling of a liquid. Boiling takes place when a liquid is heated to its boiling point. And the boiling point of a liquid is the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure, or the pressure exerted by the surrounding atmosphere, that is the atmospheric pressure. So option A says its vapor pressure is equal to atmospheric pressure, and as we've established here, the boiling of the liquid occurs when the liquid is heated to boiling point. That is the temperature at which, or when, the vapor pressure of that liquid is equal to the atmospheric pressure. So option A, its vapor pressure is equal to atmospheric pressure, is the correct answer to the question. Thank you and God bless you. Please subscribe to this channel for more videos and for more past questions and answers. Which pair of the following industrial products has a common raw material? A. Cement and H2SO4, that is tetroxysulfate 6 acid. B. Iron and aluminium. C. Margarine and soap. D. Sodium hydroxide and dyes. E. Plastic and rubber. Now let's look at the raw materials used in manufacturing each of the industrial products and see which one has a common raw material. Now cement is made using limestone, and then H2SO4 is made using sulfur, water, and then air. So you can see that the raw materials are not common, so this is not the answer to the question. Now option B, iron and aluminium. Now iron, both of them are made using ores, but the ores of iron is different from the ores of aluminium. So an example of iron ore is magnetite. Example of aluminium ore is bauxite. So you can see that these ores are not the same, so their raw materials are not common, so it is not the answer to the question. Now option C, margarine and soap, they both make use of oils, either vegetable oils or animal oils, oils of any form, lipids in general. So margarine and soap are both made using oils, they have a common raw material. Now option D, sodium hydroxide and dyes. Sodium hydroxide is made using the mercury cell setup, and then dyes are made using coal tar and other petroleum products, so they don't have common raw material. Now option E, plastic and rubber. Plastics are made using various material, but the most common one is cellulose, and then rubber is majorly made using latex. So as you can see, the raw materials are not the same, so this is also out. So as we have established here, margarine and soap are made using oils, which is a common material for both products. So option C, margarine and soap, is the correct answer to the question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 38. Environmental pollution problems are more severe in countries which have A. Great landmass, B. Low birth rate, C. Low rainfall, D. Many industries, E. Sparse population. Now, the question asks about environmental pollution, and in what countries, what type of countries will you have more severe cases of or more severe problems of environmental pollution. Now let's analyze each of the options and see which one is likely to have more environmental pollution problems. Now A says great landmass. Now statistically, countries with great landmass do not have much environmental pollution problems. Now this is owing to the fact that the great landmass means that land can be allocated far away from residential areas for industrial purposes. So because you don't have industries located close to residential areas, there are no much problems of environmental pollution. The land is enough to be maximized and used for whatever purposes can be carried out without disturbing the environment. So option A, great landmass, is not the answer to the question. Now B says low birth rate. Low birth rate means low population, and low population in a country has been linked to little or no environmental pollution problems. So as we have seen here, low population as a result of low birth rate means that there will be little or no environmental pollution. So low birth rate is not the answer to the question. C says low rainfall. Now low rainfall also cannot be linked to many environmental problems. So this is also not the answer to the question. Now option D says many industries. Now many industries are linked to or associated with environmental pollution. Okay, this is because industrial waste, okay, waste emitted by industry, so industrial waste such as toxic fumes, toxic liquid waste, etc., are known to pollute air, water, and even the soil. So the more you have industries in a particular region, the more cases of environmental pollution you are likely to have due to all these industrial wastes. So option D, many industries, is the answer to this question. In a country where you have many industries, you are more likely to have more environmental pollution problems. And lastly, sparse population is also linked to the points of low birth rate. When you have sparse population or low population, there will be little or no environmental pollution. So this is not the answer to the question. So as we have rightly established, many industries is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering NECO 2018 Chemistry Objective Past Question 39. The type of iron that is best suited for welding, making nails, chains and iron rods is A. Cast iron, B. Iron pyrite, C. Pig iron, D. Spatic iron, E. Wrought iron. So we're asked for the type of iron that is best suited for some specific purposes here, such as welding, making of nails, chains and iron rods. Now let's look at each of the options and what they are used for, and then see which one best suits the description given to us in the question. Now option A, which is cast iron. Now cast iron is majorly used in the production of stoves, tops of stoves, cookers, radiators, lamp posts, etc. Now cast iron is used in the production of materials that do not require great tensile stress. So that's what cast iron is used for. Now iron pyrite is an ore of iron. Okay, so you can't specifically say it is a type of iron, rather it is an ore of iron, a raw material in production of types of iron. Now option C says pig iron. Now pig iron has limited industrial use. Now this is because it contains high amounts of impurities, so it is very brittle and unsuitable for carrying out industrial work. Now option D says spatic iron. Now spatic iron is also referred to sometimes as siderite, which is also an ore of iron. So similar to iron pyrite, spatic iron or siderite is an ore used in the production of various types of iron, not a type of iron. Now option E says wrought iron. Wrought iron is used in the production of nails, chains, iron rods, sheets, etc. So as you can see, it is used for the production of various materials that can be used industrially. Now it is used in making nails, chains and iron rods, is what the question gives to us. And as we established here, it's wrought iron which is used in the production of those materials. So option E, wrought iron, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 40. So we have a reaction here between alkanol and organic acid to give an unknown compound X and water. So the reaction above is described as A. Dehydration, B. Esterification, C. Hydration, D. Hydrolysis, E. Saponification. Now this reaction, a reaction that involves an alkanol reacting with an organic acid or an alkanoic acid to give an ester and water. So when an alkanol reacts with an organic acid, what it gives is an ester and water. So this compound X is an ester, it's known as an ester, and water is known as, and the reaction is known as esterification. Okay, so this is what the complete reaction looks like. You have alkanol plus organic acid reacting reversibly with to give an ester and water. And for an example of this reaction, you can have ethanol C2H5OH reacting with an organic acid such as ethanoic acid to give an ester such as ethyl ethanoate and water. So this reaction is known as esterification. So esterification is option B. So option B, esterification, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers.
Good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 41. Hydrogen diffuses through a porous plug. Dash as oxygen. A. At the same rate. B. 5 times as fast. C. 4 times as fast. D. Thrice as fast. And E. Twice as fast. So now this question is just trying to compare the rate of diffusion of hydrogen to that of oxygen. And like we know, the rate of diffusion, according to Graham's law of diffusion, the rate of diffusion of gas is inversely proportional to the square root of the density. Also, you can say to the square root of the masses. Now, 1 mole of hydrogen gas, 1 mole of hydrogen is equal to, has 2 atoms of hydrogen, so the mass is 2 grams. Then likewise 1 mole of oxygen, 1 mole of oxygen will carry what? 2 atoms of oxygen. That's to form 1 molecule of oxygen, and that is what? 2 times 16, which is equals to 32 grams. Now from Graham's law, we have that what? The rate of diffusion of hydrogen all over rate of diffusion of oxygen is equal to the square root of the molar mass of oxygen all over molar mass of hydrogen. So from this we have that what? RH all over RO, now this is the rate of diffusion of hydrogen and this is the rate of diffusion of oxygen, is equal to square root of 32 all over 2, and this is equal to the square root of 16, and this is equals to 4. So therefore hydrogen will diffuse what? 4 times as fast as oxygen, and that is option C, 4 times as fast as oxygen. Thank you and God bless you, and just subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 42. A gas exerts pressure on its container because A. Of collision of its molecules with each other and with the walls of its container. B. Because of the mass of the molecule of the gas. C. Some of its molecules are inactive. D. Some of its molecules are moving faster than others. E. The molecules of a gas collide with the walls of the container. Now this can be established from the kinetic theory of gases. Kinetic theory of gases. So I urge you to go through the kinetic theory of gases to know more on this. But actually, this statement is picked from the kinetic theory of gases. Now, under the kinetic theory of gas, there's a statement that says that the pressure exerted by a gas is as a result of the collision between its molecules. That is, between the molecules of this gas, and not only that, and also with the walls of the container. Like we know, the molecule of gases are mobile. Let's take for instance, we have a container like this. Now, no matter how small that gas is in that container, you notice that the particles of these gases are always mobile. They are free, they move about, and they collide and as this occurs, they either collide with each other. There's a collision between the molecules of the gases and also collide with the walls of this container. Now, as a result of this collision, pressure is exerted by the molecule of this gas. So this pressure is as a result of collision between the molecules of the gas and also collision with the walls of the container. And that is why option A is valid and the correct answer to this question. Now, looking at option E says the molecule of gas collides with the walls of the container. Yes, this is part of it, but this is not the full reason why the pressure of gas is exerted. Like, this is not the full reason. It's as a result of a collision with its molecules and also collision with the walls of the container. So these two reasons, and that is why option A is the correct answer. And like we know, mass of gas is usually negligible. And they see some of its molecules are inactive. No, gas molecules are always active, they are mobile. So the answer to this question is option A, collision of its molecules with each other and with the walls of the container. Thank you and God bless you. Ensure to subscribe to the channel for more videos on past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 43. Cellulose and starch can be classified as A. Carbohydrates, B. Hydrocarbon, C. Isomers, D. Monohydrates, and E. Polyhydrates. So, cellulose and starch actually can be classified as carbohydrates. They can be classified as carbohydrates. Now, this is the reason because these cellulose and starch are naturally occurring organic compounds. We say they are naturally occurring organic compounds. And like you know, carbohydrates are also naturally occurring organic compounds containing carbon, hydrogen, and oxygen. This is the components of carbohydrates, with the hydrogen and oxygen present in the ratio of 2:1. That is, the hydrogen and oxygen are present in the ratio of 2:1. Now, if you look at the structure of cellulose and the structure of starch, you will see that they contain carbon, hydrogen, and oxygen only, and the hydrogen and oxygen ratio is 2:1. Although cellulose and starch are polysaccharides, we call them polysaccharides. They are polysaccharides because they consist of more than 2 units of monosaccharides. They are complex they are complex carbohydrates, but they are actually carbohydrates because they are naturally occurring organic compounds containing carbon, hydrogen, and oxygen, and their hydrogen to oxygen ratio is 2:1, just like the characteristics of carbohydrates. Now, option B here says hydrocarbon. Hydrocarbon are only compounds that contain carbon and hydrogen. Those are hydrocarbons. That is called hydrocarbon. Example is the methane, the ethane, the butane. Now, option C says isomers. Isomers simply refers to two compounds or two or more compounds having the same molecular formula, but different structural formula. That's isomer. An example is when you see you see butane and 2-methyl propane. So these are what isomers. Then option D says what? Option D says monohydrates. Monohydrates are compounds that just contains one molecule or 1 mole of water. They contains 1 mole of water. Example is the ferrous sulfate. That's the FeSO4.H2O. You see that the water component here is just what? 1 mole. So we call it a monohydrate. Then for polyhydrates, polyhydrates contains more than 2 moles of water. An example of a polyhydrate is the copper 5 sulfates. That is dehydrated copper 5 sulfates, copper 6 sulfate, sorry, SO4 MCuSO4.5H2O. Now this is a what? Polyhydrate. So the answer to this question is option A, carbohydrates. Cellulose and starch can be classified as carbohydrates. So that is the answer to this question. Option A is the correct answer. Thank you and God bless you. Ensure to subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 44. The compound 2,2-dimethylpropane is an isomer of A. Butane, B. Hexane, C. Methane, D. Pentane, and E. Propane. Now, 2,2-dimethylpropane is given as this: C, C, C. That this is the carbon, carbon, carbon. Since it's propane, so it's a single bond. Then since the methyl group is attached to the second carbon atom, that is 2-methyl group, that is dimethyl, it's attached to the second carbon atom. This is the second carbon atom. So we have one methyl group here, one methyl group, and another methyl group here. This is another methyl group. Now this is the 2,2-dimethylpropane. Now they are asked that this is an isomer of what? Like we know, isomers are two compounds having the same molecular formula, but different structural formula. Now that is isomer. Those are isomers. Now looking at this, the molecular formula of 2,2-dimethylpropane will be, since it's having 5 carbon atoms, it will be C5H12. How? Now let me complete the hydrogen atoms. Hydrogen, 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 hydrogen. Now let's count the carbon atoms. 1, 2, 3, 4, 5. The hydrogen atoms: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the molecular formula of this, and this is the structural formula. Now that means it has 5 carbon atoms. Like I say isomers have the same molecular formula but different structural formula. Now which of this compound here has the same molecular formula as this? Butane here has 4 carbon atoms, so it is wrong. Hexane has 6 carbon atoms, so it is wrong. Methane has just 1 carbon atom, it is also wrong. Propane has 3 carbon atoms, so it is wrong. But looking at option D has what? 5 carbon atom, pentane. 5. Now so therefore, since this is pentane, its molecular formula will be C5H12. Now let's briefly describe the structural formula. Now the structural formula of pentane, since it is a straight chain hydrocarbon, we have C. So 1, 2, 3, 4, 5. Now attaching the hydrogen, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see that it is complete. But now looking at the structure of pentane, it differs from the structure of 2,2-dimethylpropane. So therefore, since they have the same molecular formula and different structural formula, we can say 2,2-dimethylpropane is an isomer of pentane. And so therefore, pentane is the correct answer to this question. Option D. Thank you and God bless you. Ensure to subscribe to the channel for more videos on past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 45. An element E has electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p4. To which group and period of the periodic table does E belong? So the options are A, group 1 and period 4, B, group 2 and period 4, C, group 3 and period 3, D, group 6 and period 3, and E, group 7 and period 2. Now, like we know that this 1, 2, 2, 3, 3 here represents the energy level of this element, that is, it represents the shell of this element. And like we know, the current shell or the outermost shell of the element represents the period of this element. What I mean is that if it is the first shell, that is the outermost shell, it means that this element belongs to what? Period 1. If it is the second shell, that is the outermost shell, it simply means that it belongs to what? Period 2. But from this electronic configuration, we have 3 here, meaning that the outermost shell is what? Is 3. And so therefore this element belongs to period 3. Now that is that for the period. For the group now, to find the group of this element, for if this element was to be in group 1, group 1 will be carrying what? S. That's group 1 will be carrying 2 elements or 2 electrons on the s orbital. 1 electron, sorry, on the s orbital. Then if it's for group 2 will be taking what? Group 2 will be taking 2 electrons on the s orbital. Now for group 3 will be taking what? 2 electrons on the s orbital, that is the outermost orbitals now, that is the 2 electron on the s orbital and 1 electron on the p orbital. So if you add them together, 2 plus 1 will give you what? 3. For group 4, you will have what? 2 on the s orbital and 2 on the p orbital, giving you what? 4. That's group 4. For group 5, we'll be having s2 p3. 2 plus 3 will give us what? 5. For group 6, we'll be having s2 p4. 2 plus 4 will give us what? 6. And for group 7, we'll be having s2 p5, and that will be what? 7. Now the question given to us here is what? s2 p4. So 2 plus 4 will give us what? 6. Therefore this element belongs to what? Belongs to group 6 and period 3, and that is option D, group 6 and period 3. Thank you and God bless you, and subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 46. The type of reaction between alkenes and halogen is A. Addition, B. Oxidation, C. Polymerization, D. Reduction, and E. Substitution. Now, alkenes is a homologous series of hydrocarbon that has the general formula CnH2m. H2n. So this is the formula of alkenes, and this is due to the presence of double bond. Now, alkenes, or a typical example of alkene, or the first member of this family, is the ethene. H, or let me say H. So because of the presence of this double bond, it can only be attached to 2 hydrogen atoms, that is, each carbon atom can be attached. So this is ethene, and ethene has the formula C2H4. Now, alkenes can only undergo addition reaction. Now, addition reaction with involving halogen simply involves what? The addition of halogens to alkenes to thereby eliminate this double bond, making it was a single bond. An example is the reaction of this ethene with chlorine. Now let me write out the reaction. We have ethene CH2, this is ethene plus chlorine, 1 molecule of chlorine. Now this will give us what? CH2Cl. Now if you look at this, the double bond has been broken, thereby attaching what? 2 atoms to this molecule. So therefore we say ethene plus chlorine will give us what? 1,2-dichloroethane. 1,2-dichloroethane. Now if you look at this reaction, we added chlorine to this ethene. We did not substitute anything. Nothing was substituted. Substitution simply means that an atom will be what? Substituted. That is, maybe a hydrogen atom will be substituted with chlorine. But that was not done here. What we did here was addition. And so therefore, the type of reaction between alkenes and halogens is the what? Addition reaction. And like I told you, alkenes can only undergo addition reaction with halogens. But for alkenes undergo what? Substitution reaction. And this is because what? They already have what? They are already saturated. But alkenes are not saturated because of the presence of double bonds. So addition of chlorine will break this double bond and make them saturated. But because alkenes are already saturated, they can only undergo substitution reaction, that is, replacing the hydrogen atom with another what? Halogen atom. Also, the alkynes can undergo both addition and substitution reaction. Both addition and substitution reaction. That's for the alkynes. So take note of this. Alkenes can only undergo addition, alkane only substitution, and alkyne both addition and substitution reaction. So the answer to this question is option A, addition reaction. Thank you and God bless you. And subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 47. When starch undergoes complete enzyme catalyzed hydrolysis, the product is A. Cellulose, B. Fructose, C. Glucose, D. Maltose, and E. Sucrose. Now the question is that when starch undergoes complete enzyme catalyzed hydrolysis, complete enzyme catalyzed hydrolysis. Hydrolysis simply means addition of water. So to break the bonds now between the components of starch. Now the product is, now a typical example of this enzyme catalyzed hydrolysis occurs in the mouth, whereby the enzyme present in the saliva, hydrolyzes starch. It hydrolyzes starch. Like we know, the enzyme present in the saliva will what catalyze this reaction of hydrolysis. So it hydrolyzes starch into maltose. Now normally hydrolysis of starch will give you maltose and dextrin, but a complete enzyme catalyzed hydrolysis, like the type that occurs in the mouth due to the enzyme present in the saliva, would hydrolyze starch into maltose. So therefore maltose is the correct answer. Now looking at this, option A says cellulose. It will not give what? Cellulose, because cellulose already on its own is not a component of starch. Then B says fructose. So, and it is not what? It will not be given when starch is fully hydrolyzed. C says glucose, which is also a monosaccharide, also will not be given when starch is hydrolyzed. So maltose is what produced when starch is hydrolyzed by complete enzyme catalyzed hydrolysis. So the answer to this question is option D, maltose. Thank you and God bless you, and subscribe to the channel for more videos and past questions. Good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 48. The most suitable indicator for a titration of sodium hydroxide with ethanoic acid solution is A. Litmus, B. Methyl orange, C. Methyl red, D. pH meter, and E. phenolphthalein. Now, the titration of sodium hydroxide and ethanoic acid solution is the titration of a strong base and a weak acid. Sodium hydroxide is a very strong base and ethanoic acid is a weak acid. So it involves the titration of what? Sodium hydroxide, which is a strong base, and ethanoic acid, which is a weak acid. And like we know, indicator used for titration depends on what? On the strength of these reactants, either being it a strong base or a strong acid, or strong base weak acid, or weak base strong acid, or weak acid weak base. Now let's just briefly describe what indicators simply mean. Indicators are weak organic, they are weak organic acids or base which will produce different colors in solution according to the hydrogen ion concentration of this solution. So now, depending on what the hydrogen ion concentration of this solution, and like I said, the question given to us is about a strong base and a weak acid. Now the suitable indicator to be used when titrating a strong base against a weak acid is phenolphthalein. So phenolphthalein is used for a strong base and a weak acid, and that is option E. Now A says litmus. Litmus can be used for a strong acid and a strong base. For a strong acid and strong base. B says methyl orange. Methyl orange is used for a strong acid and a weak base. C says methyl red. Now methyl red can be used for what? For a strong acid and a strong base. So this is pH meter. Now pH meter is not an indicator. It's not an indicator. So the answer to this question, like I said, is option E, phenolphthalein, which is used for what? Is used for a strong base and a weak acid. And like you know, sodium hydroxide is a strong base and ethanoic acid is a weak acid. So the answer is E, phenolphthalein. Thank you and God bless you. Ensure to subscribe to the channel for more videos. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 49. In the manufacture of glass, some transition metal oxide are used: A. For chemical durability, B. To increase the transparency, C. To make it malleable, D. To make them luster, and E. To add color. Now, during the manufacture of glass using silicon 4 oxide, now transition metal oxides are actually added in order to give this glass color, to give color to the glass. Now this is possible because each transition element or transition metal has their characteristics color. They have their characteristic color. Like we know, these transition metals, they have they have color. Now addition of a characteristic transition metal to a glass will give it its own characteristic color, and this is how colored glasses are being produced. So colored glasses are produced by addition of appropriate transition metal oxides to the silicon 4 oxide when producing this glass. Now option A is for chemical durability. This is achieved when powdered glass and coke are being added. When powdered glass plus coke are added. B says to increase its transparency. No. C says to make it malleable. Like we know, glasses are not malleable. They cannot be beaten into sheet because what? They are brittle. And this is to make them luster, that is to shine. No, that is not it. So the answer is option E, to add color to the glass, to give them what? Their appropriate color. That is the reason why transition metal oxide are added. Thank you and God bless you. And just subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 50. Carbon 4 oxide in air can be absorbed by passing it through A. Alkaline paragonal, B. Concentrated sodium hydroxide, C. Concentrated tetrasulfate 6 acid, and D. Ethanol, and E. Fused calcium chloride. Now, carbon dioxide CO2 is actually absorbed, or is generally absorbed by alkalis. That's alkali solution. So generally, alkali solution will absorb what? Carbon dioxide from any what? From any place readily. But then the alkali solution that will readily absorb carbon dioxide from the air is alkaline pyrogalol. Alkaline pyrogalol. Now you can see option B. Option B says concentrated sodium hydroxide. Yes, sodium hydroxide is capable of absorbing CO2, but then it is not capable of absorbing what? CO2 from the air as alkaline what? Pyrogalol. Alkaline pyrogalol is the most suitable for absorbing carbon 4 oxide, which is CO2, from the air. When air is passed over alkaline pyrogalol, either in the preparation of, in order to prepare nitrogen, you can prepare nitrogen or oxygen from the atmosphere. Now once it is passed through alkaline pyrogalol, carbon 4 oxide will be trapped. In the entire carbon 4 oxide in the air will be trapped by this what? Alkaline pyrogalol. So alkaline pyrogalol is more suitable for absorbing what? Carbon 4 oxide from the air. Now, concentrated tetrasulfate 6 acid and fused calcium chloride are drying agents. These are drying agents. So the answer is A, alkaline pyrogalol. Thank you and God bless you. Please ensure to subscribe to our channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 51. Which of the following factors does not affect the rate of chemical reaction between non-gaseous reactants? A. Concentration of reactants, B. Presence of catalyst, C. Pressure, D. Surface area of reactants, and E. Temperature. So we're asked to pick an option which will not affect the rate of chemical reaction for a non-gaseous reactant. That is, the reactant is either a solid or a liquid form. Now first of all, what is rate of chemical reaction? Now rate of chemical reaction simply refers to the number of moles of reactants converted or products per unit time. Now all these factors will affect the rate of chemical reaction for a reactant which is either solid or in gaseous form, except pressure. Now according to collision theory, or from the collision theory, it is stated that pressure will only affect the rate of chemical reaction of gaseous reactants, whereby concentration will only affect the rate of chemical reaction for a solid or liquid reactant. So in terms of pressure, it deals with what? Gaseous reactants, but in terms of concentration, it deals with what? Solid or liquid reactants. So therefore, pressure will not affect the rate of chemical reaction for a non-gaseous reactant, that is either solid or liquid. But then the concentration of reactants will affect it, because it is in solid or liquid. It's not a gaseous form. And if it is in gaseous, then concentration will not affect it, to be pressure. Then presence of catalyst, like we know, affects the rate of chemical reaction. It increases the rate of reaction. Surface area of reactants also increases the rate of chemical reaction. That is, the larger the surface area, the more the rate of reaction, that is, there will be an increase in the rate of chemical reaction. And also temperature too affects the rate of chemical reaction. The higher the temperature, the higher the rate of reaction. But for a non-gaseous reactant, pressure do not affect it. Pressure only affects for gaseous reactant. So the answer to this question is option C, pressure. Thank you and God bless you. And just subscribe to the channel for more videos and past questions. Hello, good day and welcome. I'll be answering NECO 2018 Chemistry Objective Past Question 52. Which law is obeyed when volume is doubled and pressure is halved? A. Boyle's law, B. Charles' law, C. Gay-Lussac's law, D. Law of constant composition, and E. Law of reciprocal proportion. Now this question is that the volume was doubled. That is, let's say we have V1, then it was what? Doubled. So we had 2V1. And then the pressure is halved, meaning that we had P1 initial pressure and then it was halved. That's P1 all over 2. Now looking at this, you'll notice that since the pressure was doubled and the volume was doubled, what happens? There was a decrease in the pressure by half. And this statement simply implies what? That the volume is inversely proportional to the pressure. Thereby we will say V is equals to what? K, that's introducing a constant, all over P. And so therefore we say Vp is equals to K. And therefore V1 P1 is equals to V2 P2. Now looking at this statement, this is what? This is Boyle's law. Boyle's law, which states that the mass or the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature is constant. And if you look at this, you'll notice that what, because of this inverse proportion, since they say what increase in the volume by 2, that is the volume was increased by what, by doubling it, there will be what, a decrease in the pressure by half. So this statement is what is Boyle's law. For Charles' law simply states that what volume is directly proportional to temperature, provided that what pressure remains constant. And for Gay-Lussac's law states that Gay-Lussac's law is a law of combining volumes, which states that when gases react, they do so in volumes. That is, the gases react in volumes which are simple ratio to one another, and then to the volume of the products if gaseous, provided that the temperature and pressure remains constant. Then the law of constant composition, also known as law of definite proportion. Law of definite proportion states that all pure samples of a particle of a particular chemical compound contains the same elements in the same proportion by mass. So that is a law of what? Constant composition. Now the law of reciprocal proportion states that the masses of several elements, let's say for instance we have several elements A, B and C, that the masses of these several elements which combine separately with a fixed mass of another element D are the same as the simple multiples of the masses in which A, B and C themselves combine with what? Combine with one another. So these are what these laws actually what stated. But from this expression here, that volume is doubled and pressure is halved, it is typically what? Boyle's law. And that is option A, Boyle's law. Thank you and God bless you. And just subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 53. A plastic which can be softened by heat is described as A. Non-biodegradable, B. Nylon, C. Polypropylene, D. Thermoplastic, and E. Thermoset. And like we know, a plastic is a polymer. Polymers are compounds which are gotten from the what? From polymerization reaction, that is, they consist of different monomers. So monomers come together via polymerization to produce what? Polymers. Now, since plastic is a polymer, It is divided into two types. We have the thermoplastic and the thermosets. Now each of these types has their characteristics. Now for the thermoplastic, the thermoplastic, which is a plastic polymer, can become softened or can become soft when heat is applied or when heated, and can also become hard again when cooled. So it simply means that a thermoplastic can be heated over and over again to change its shape or form. But for a thermoset plastic, it cannot be softened again when heat is applied or when heated. This is because during the formation of this thermoset plastic, it is irreversibly hardened. During its formation, it is irreversibly hardened. So even when heat is applied, it is impossible to soften this plastic to form a new shape. So the plastic which can be softened by heat is described as the thermoplastic, which is option D. Like I have described, the thermoplastic is the plastic that has the ability to become soft when heat is applied and hard when cooled, and this can be done several times. So the answer to this question is option D, thermoplastic. Thank you and God bless you. Ensure to subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 54. The complex salt formed when aluminium dissolved in sodium hydroxide solution is A. Na3 AlOH4, B. Na2 AlOH3, C. Na AlOH3, D. Na AlOH2, and E. NaAlOH4. Now, when aluminium dissolves in sodium hydroxide, aluminate 3 is formed. That is, soluble aluminate 3 is formed. And not just that, with evolution of hydrogen gas. With evolution of hydrogen gas. Now let me give this with the equation. Now we're given that aluminium reacts with sodium hydroxide. So plus H2O. Now this water here will enable this reaction to take place. So we require 2 moles of aluminium to react with 2 moles of sodium hydroxide, and this will give us 2 moles of soluble aluminate 3, which is NaAlOH4. Then, like I said, plus the hydrogen gas. Now this is the reaction, and this reaction is also the same for potassium hydroxide. So aluminium will react with sodium hydroxide in the presence of water to give us the aluminate 3 and also liberate hydrogen gas. And if you can see this is option E. And this is the reason why sodium hydroxide is not used, or is never used, to clean aluminium vessel. So that is why sodium hydroxide, also known as caustic soda, is not used to clean aluminium vessel, because it will definitely react with this aluminium to produce aluminate 3. So the answer to this question is option E, aluminate 3. So aluminium dissolves in sodium hydroxide to form this. Thank you and God bless you. Ensure to subscribe to the channel for more videos and past questions. Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 55. The random motions of molecules are greatest when a substance is changing from A. Gas to liquid, B. Gas to solid, C. Liquid to gas, D. Liquid to solid, and E. Solid to liquid. Now, random motion, like we know, is greatest in gases. This is because what? The particles of gases are free. They are not as tightly bound as those of what? Solid, and likewise as those of liquid. So the particles of gases, or the molecules of gases, are free, and they are able to what? To move randomly in a given container. Likewise, also the random motion of liquid is also greater than that of solid. Why? Because the particles of liquid are free compared to that of what? Solid. Now, random motion will be greatest when changing from what? From liquid to gas. This is because those particles or the molecules of liquid are free than the molecules of solid, and so therefore the random motion in this liquid is more than that of solid. Now, changing from liquid to a gas, we are increasing the random motion of this substance, because the random motion of gas in general is greater than that of liquid. So it will be what? Be from liquid to gas. So random motion of molecules are greatest when substance is changing from what? From a liquid to a gaseous state, because the molecules of gas are free. They are free to move about in a given what? Space or container. So the answer to this question is option C, liquid to gas. Thank you and God bless you, and subscribe to the channel for more videos on past questions.
Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 56. The following are periodic properties except A. Activation energy, B. Atomic radius, C. Electron affinity, D. Electronegativity, and E. Ionization energy. So we are asked to pick an option which is not a periodic property. And like we know, periodic properties actually describes an atom, or they just describe the activities of an atom, of an element. Now, let's briefly look at all these options. Option A says activation energy. Now, activation energy is that minimum energy that must be possessed or required by a reactant in order to form a product. Now, if you look at this activation energy, you see that activation energy does not describe the activities of the atom, or neither does it describe the properties of this atom or element. It just simply describes the reaction. That is, it is the energy that is required by every reactant before they can complete a reaction, that is, before they can give a product. But now, looking at option B, atomic radius. Atomic radius can simply be defined as half the distance between the nucleus of two atoms. That is, half the distance between the nucleus of two similar atoms. Let's say, for instance, we have two atoms like this and another atom like this, and this is the radius of this this is the nucleus of this atom. Now, this is the distance between these two nucleus. Now, half this distance is what we call the atomic radius. So you can see that atomic radius is describing describing the distance between the nucleus of two atoms. So it's describing the atom. So we can refer to it as a periodic property. Option C here says electron affinity. Electron affinity, which is option C. Now, electron affinity is simply the energy released when a gaseous atom gains an electron. Energy released when a gaseous atom gains an electron. When a gaseous atom gains an electron. So electron affinity is that energy released when a gaseous atom gains an electron. Now you can see that it is affecting the activities of the atom. Now, a gaseous atom is gaining an electron. So it is a periodic property. Now, electron affinity, electronegativity now, which is option D, is the power of that atom in a molecule to attract electrons. Power of an atom to attract electrons. Now you will see that what it still follows the same trend. It is describing the atoms of these elements. Now E here says ionization energy. Ionization energy now is just like the energy of an atom or the energy of an element that is required to remove an electron. That is energy required to remove an electron from a gaseous atom. Now you can see that option B, C, D, and E are all what they are all periodic properties because what they describe the atom. But looking at option A, it is not a periodic property because it is describing a reaction that is involving reactants in order to produce products. So the answer to this question is option A, activation energy. It is not a periodic properties. Thank you and God bless you. Ensure to subscribe to the channel for more videos and past questions.
Good day and welcome. I'll be answering NECO 2018 Chemistry Objective Past Question 57. A particle that contains 13 protons, 14 neutrons and 10 electrons is A or an A, atom of metal, B, atom of non-metal, C, negative ion, D, neutral ion, and E, positive ion. Now, a particle contains 13 protons. This simply means that the atomic number of this atom or this particle is 13, and from the periodic table the element with atomic number 13 is aluminium. Now already we can ascertain that this aluminium is an atom, this particle is an atom of metal, but that is not complete from the description given to us, because we know that the proton number and number of electron of an atom is the same. But now we're giving 13 protons and 10 electrons. It simply means that this atom or this particle has lost 3 electrons. Now, since it loses 3 electrons, this atom or particle can be represented as Al3+. That means this 3+ simply means it requires 3 electrons for it to complete. So it's short of 3 electrons. Now looking at this is an ion, because ion are described as atom with charges, either positive or negative charge. So this is an ion. Now because it's carrying a positive charge, we say it is a positive ion. Remember, like I said, although it is a atom of a metal, but that has not ascertained the true nature of this particle. So the true nature of this particle is that it is a positive ion, because it's carrying a positive charge, and this is the atom of an aluminium. So the answer to this question is option E, positive ion. Thank you and God bless you. Ensure to subscribe to the channel for more videos and past questions.
Hello, good day and welcome. I'll be answering NECO 2018 Chemistry Objective Past Question 58. The type of bond between atoms of an element with atomic number 7 each is A, coordinate covalent, B, covalent, C, hydrogen, D, ionic, and E, metallic. Now, an element with atomic number 7, or the element with atomic number 7 from the periodic table, is nitrogen. So basically, we are being asked the type of bond between the atoms of nitrogen. Now, since nitrogen has 7 proton numbers, which is the atomic number, therefore it has 7 electrons. So 7 electrons. Now remember, it is these electrons that is involving in bond formation. So an atom of nitrogen will be represented as this. So we have 1, 2, 3, 4, 5. So when you count all these together, is 1, 2, 3, 4, 5, 6, 7. Now plus another atom of nitrogen, 1, 2, 3, 4, 5, 6, 7. Now when these chemically react together, they will give, now there are 3 electrons here that are lone, that is, they are not paired. We have only 1 paired electron and 3 unpaired electrons. Likewise, on this other atom too of nitrogen, there are 3 unpaired electrons here. Now these 3 unpaired electrons of this atom here will share its unpaired electrons with the unpaired electrons of this to give paired electrons, so that their configuration can be stable, giving rise to, we'll have something like this. And these are the 2 atoms, 1, 2, 1, 2. Now these 2 atoms will now share their electrons amongst themselves. So 1, 2, 1, 2, and 1, 2. Now if you count these total electrons outside now, then plus the other one, 1, 2, 1, that's the paired electrons. Now when you count it together, you see that the electrons now are now complete on each atom, which is 1, 2, 3, 4, 5, 6, 7, 8. That is, now for this paired electron, now you can see that they've shared it. This has shared its paired electron with this, and likewise this has shared its paired electron with this. So you've seen that they have a stable octet structure now, because this one now is complete shared, that is paired. This is also paired, and paired. So having 8 electrons on its outermost shell, and same too for this paired here, paired, having 8 electrons on its outermost shell. So we can now call this the nitrogen molecule. Now this type of bonding is what we call covalent bonding, because covalent bonding is a type of bonding whereby the atoms involved in this bonding share electrons. They share their electrons. So that is option B. Now in terms of coordinate covalent bonding, in coordinate covalent bonding, only one atom donates the electrons to be shared. So one atom donates the electron to be shared. But for the covalent bonding, you can see that both atoms donated the electrons. This donated one, they shared it, which is this. This donated one, they shared it, which is this. And this last one donated it, and they donated the last one, which is this. So you can see that is covalent bonding. Now in terms of hydrogen bonding occurs between hydrogen and oxygen, hydrogen and nitrogen, and hydrogen and fluorine, most especially. So the bonding between these is mostly hydrogen bonding, and this hydrogen bond is a very, very strong bond that keeps them together, and this hydrogen bond enables the product to be soluble in water. Now this here says ionic bond. Ionic bond simply involves the transfer of electrons. Usually from a metallic atom to a non-metallic atom. The metallic bond is a type of bond that occurs in metals, that is the atoms of metals. So the answer to this question is option B, covalent bond, because of the sharing of electron among these 2 atoms. That is, both atoms donated the electrons to be shared. Thank you and God bless you. Ensure to subscribe to the channel for more videos and past questions.
Hello, good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 59. When pollen grains are suspended in water and viewed under a microscope, they appear to be in a state of constant but erratic motion, that is a random motion. Now this is due to A chemical reaction between polygrain and water, B convectional current, C small changes in pressure, D small changes in temperature, and E the bombardment of pollen grain by the molecules of water. Now when polygrains are suspended in water and viewed under microscope, it will be observed that they will be in a constant but erratic or random motion. Now this is a phenomenon known as Brownian motion. During the experiments, it was observed that when a pollen grain is placed in water and viewed under microscope, that these pollen grains begins to move haphazardly, that is, their motion is haphazard and random, that is the erratic motion here, and constant. Now this is actually due to the bombardment. It is due to the bombardment of the suspended solid particle. In this case, the pollen grain now is a solid particle, by the surrounding molecule of liquid medium, and in this case the water is the liquid medium. So due to the bombardment of these particles of these pollen grains by the surrounding molecules of water, that is what brings about the constant but erratic motion of these pollen grains when observed under a microscope. And that is option E, the bombardment of pollen grains by the molecules of water. So this is actually the phenomenon or the activity that brings about this Brownian motion. Brownian motion is the erratic motion observed. So the answer to this question is option E. Thank you and God bless you. Make sure to subscribe to the channel for more videos and past questions. Good day and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 60. Which element does not exhibit allotropy? A. Carbon, B. Magnesium, C. Oxygen, D. Phosphorus, and E. Sulfur. So we are asked for the elements that do not exhibit allotropy. Now allotropy is a phenomenon, or we can say is the ability of an element to exist in various forms but in the same physical state. Now looking at option A, which is carbon. Carbon exhibits allotropy, because carbon has allotropes, and these are diamond and graphite. Although there are more allotropes of carbon, but diamond and graphite is the most typical example of the allotropes of carbon. Option B says magnesium. Now magnesium do not exhibit allotropy, so it has no allotrope. Option C says oxygen. Oxygen exhibits allotropy. It has allotropes, that's the normal oxygen O2 and ozone O3. Now option D says phosphorus. Phosphorus also exhibits allotropy, and these are the white, the red, and black phosphorus. Then lastly, sulfur. Sulfur too exhibits allotropy. These are the rhombic sulfur and the monoclinic sulfur and monoclinic sulfur. So all these are the allotropes of sulfur. Now you see that from this description, only magnesium here do not exhibit allotropy, that is, do not has allotropes. And so therefore magnesium is the answer to this question, because the question is asking us for an element that do not exhibit allotropy. So the answer to this question is option B, magnesium. Thank you and God bless you. And subscribe to our channel for more videos and past questions.